Go.
My name is Larry Ischler, and I'm CEO of LWI Associates, an engineering consulting firm based in Erie, Pennsylvania. We have over 1,000 consultants and associates located around the United States. We develop new products for individuals and firms who are interested in using our services. We take ideas and convert them into products. I'd like to talk specifically about one of the ideas and the process we use to convert the idea into a product. We have an 8-step process which starts with design of the complete system and finishes with testing the whole system. Right now we have a number of products in development. The one that I want to focus on today is in the component manufacturing phase. It's called NBG. It's a non-invasive blood glucose monitor. For the past 12 years, since my son was diagnosed as a type 1 diabetic, I've been working on the development of this particular product. People have to test their blood glucose level because the same individual or the same amount of food consumed by different individuals results in different blood glucose level, as seen in this chart. Some individuals have relatively small changes. Other individuals, particularly type 2 diabetics, have very large changes in their blood glucose level as they consume food. I worked on the physics of the problem and developed a relationship between the blood glucose level and the temperature of 2 points on your ear. The differential temperature for each 24 millikelvin or thousandths of a degree C, your blood glucose level changes 1 milligram per deciliter. I confirmed this with using a $100,000 infrared camera to figure out where on the body you get the most change per unit change blood glucose level. I did this using arms, hands, ears, and set up in a motel room, tested a number of people, and saw their temperature gradients change. The gradient changed in all the parts of the body, but the biggest change per unit change in blood glucose level was in the ear. I started with a relatively low blood glucose level, consumed a Pepsi and a candy bar, and then 1 hour later you can see by the increase in the red amount on the ear how the blood glucose increased. After 135 minutes, reached a maximum and resulted in this change in glucose level. You can see in a larger plot the before and the after. And you can see the red indicates higher temperatures. You can see how much more red there is, and the pink is the highest temperature. I used this information to develop a correlation between blood glucose level and your temperature. And I found that if you were less than half a degree difference at the 2 points on the ear I used for the measurement, your glucose level was over 250 milligrams per deciliter. And if your difference was around 2 degrees centigrade, then the blood glucose level was around 80. I confirmed this with a study on an individual that I'd never met before. The individual sat in a room with the temperature sensors connected and compared those results to results using finger stick method. And we used 2 different finger stick instruments because I later found out that the variation in the finger stick instruments is greater than 29%. If it read 100, it could be 129 or it could be 80. I had a problem during the test. The sensor came loose from the ear, and so I had to modify the results slightly to compensate for the slight decrease in temperature. And then the correlation was very good. 90% of the results were clinically acceptable during this test. I've also done a lot of tests comparing multiple finger strip tests where you prick your finger, put blood on a strip, and then measure the value of the strip, to my method of measuring temperature, and found that my method is within 6 milligrams per deciliter of the average of the two measurements, a little less than 3% different. So I believe that I've found a correlation that is very accurate. Now, why does this happen? Well, fundamentally, the brain converts glucose very rapidly. In fact, depending on the value of the glucose in the blood, up to 90% of it is converted. When that conversion occurs, energy is released, which tends to increase the temperature of the brain. The hypothalamus doesn't like temperature increases. Its function is to maintain brain temperature, so it causes vascular dilation, and more blood flows to the ears. When more blood flows to the ears, that warm blood heats the ear, and so the temperature differential decreases. So we have an inverse relationship between the glucose level and the temperature difference on the ear. I'd like to, at this time, demonstrate the actual measurement system and actually do a measurement. The first point is right here. And it'll take a second to stabilize. Actually, it takes about 15 seconds. And as the resistance goes down, that means the temperature is increasing, so the thermistor is measuring increase in temperature. And it's pretty stable there, 7.40 kiloohms. And now I'll move to the second point, and you can see it's getting cooler because the resistance is increasing, and this is an inverse relationship between temperature and resistance here. And you can see the temperature going up. It's pretty stabilized. So that difference in the two resistances is about 240 ohms, which is about 1 degree. And so if I go back here, you can see that the current blood glucose level is between 120 and 150 at that temperature delta. Thank you, and I hope that I'd be able to develop a new product for you sometime in the near future.